Okay. Good evening, everyone. Welcome back to e-commerce analytics. And today would be day 5. Yes, we had 4 sessions last week, and we'll have 4 sessions this week. So now, before we get started, uh, just as a quick overview, I would like to know what everyone was up to this weekend. Like, did you guys do anything special? Looks like nobody did anything, huh? That's fine. I can understand that happens a lot. Okay. So, anyways, up until last session, we were dealing with unsupervised unsupervised ML models, and now we'll be dealing with supervised. But just as a quick recap, unsupervised, why is not known. Why, in the sense, the output we don't know which is the output. We just know that there is some sort of pattern. Okay. So now we'll move on to supervised learning. Now, in supervised learning, the biggest difference is y is known. So, if you have a data, you'll have y is known. That means you know what output you want. Okay. So now in supervised, you end up with two different types of models. You got classification and you got regression. All right. So quickly, we'll just switch over to a different screen. Okay. Okay. So we have classification and we have regression. Now, what is the key point to remember here? In classification, the y is categorical. Now, let's say I am collecting some information about churn of customers. So if I say that, will the customer order again? Yes or no? This is what we call, this is where we will classify, use a classification technique. Okay. And similarly, if I'm predicting the future sales price, we'll end up with a scenario where you might have 110.41, 20.8. Now this is where you have regression. Here y is numeric. Okay. So this is the basic difference between regression and classification. Now, what we are taking a look at today is what we call KNN. Now, what is KNN? KNN is K nearest neighbor. Now, K nearest neighbor, what we are trying to find here is the nearest neighbor for every data point. So we have KNN. Yeah, K nearest neighbor. Now, in KNN, what we are trying to find is where will, let's say you have 100 data points and you're given one new data point. Where will this data point be classified be classified based on the existing 100 data points, based on this. So, okay, why? How it will do is it will try to find the similarity between the data points. Okay, so if you are given some data points, let's say this is a distribution. Okay, so here we have some data points like this, and some data points like this. Okay, and then let's just select the darker shade. Now, if you have this new data point coming in, which group will this data point be placed? That is what will determine with K and N. Okay. So how does this algorithm work? So for any data point, okay, any individual data point, KNN will find the distance. Okay. Distance between what? The data point and K number of data points. How many data points you want to take? That is K, number of data points. So you could have 10, you could have 5, you could have 1. Okay. Okay. And it will vote for the category that is most frequent. So if you have 5 categories, it will pick which category is most frequent. Okay. All right. So we have. So for this distance, we take Euclidean distance. Now, what is Euclidean distance? Euclidean distance is distance between 2 points, x1, x2 squared plus x2 minus x3 squared, like that, and then you're taking the square root of that. So that is Euclidean distance. Okay. So for KNN, we usually take by default Euclidean distance. Of course, there are other distance metrics. So if you want to take any different one, you can obviously take it. Okay. So that is the basic. So what happens is at the end of the day, you just end up with some data that is labeled based on its nearest neighbor. Okay, it looks something like this. Okay, looks something like this. So this is what you end up with. Okay. So what is the use of KNN? It is used in genetics. Now, the thing about genetics is you carry over a lot of genetic material from your ancestors. Similarly, you carry on genetic material from animals that you are linked to. Okay. And even in animals, it is the similar scenario. The genetic material is carried over from generations to generations. Of course, it gets modified based on your living situation. It gets modified based on where you're living, what is your economic status, what type of food you're eating. And of course, like, you know, if you have a genetic of this man and a woman, obviously their children will have both genetic materials, right? So like this, you end up with the exponential tree. Okay. They will have like, if they have three children and their children get married and they have three children each, right? They have three children. This is, yep. They have three children. They have three children. They have three children. So like that, your genetic pool is getting diversified. But again, you know, there are some similarities that you can trace back to this original couple. So we use KNN to classify you people based on genetic similarity. Then we also have forecasting. Now, how would it work in forecasting? What are you doing in forecasting? In forecasting, you're trying to predict a future outcome, right? So let's say, okay, let's say you're trying to predict your sales in season and out of season. Now, what do you understand by in and out of season? Okay, so in season means, let's stick to some examples. Let's say you have um, what do you call it? Let's say you have Diwali sales. Now, whatever you're selling during the Diwali festival, during that period, whatever, be it clothes, be it some sort of, be it like firecrackers, or be it anything, be it some sweets. Now, these items, when they are being sold in Diwali, would they have a similar sale throughout the year? They would not have a similar sale throughout the year. They would have less of a sale. Now, if you have firecrackers, when you will see a lot of firecrackers, maybe in India, at least during New Year's, obviously Diwali is there. Whenever you have the wedding season in your local region, for example, in Punjab, it's November, December, when the weather is really nice. So in this period, you can expect a lot of increase in sales of firecrackers. Similarly, outside of this specific period, like Diwali is in October or later, it's in January. Out of this 3 month period, is your firecrackers, are there going to be a huge amount of sale for your firecrackers? There won't be any sale for your firecrackers. There will be some sale, obviously. You cannot say that there will not be sale. But if you're selling, for example, 1,000 units a day during the season, in season, you might end up with a scenario where you're selling only 50 units a day out of season. Bisakhi is another one. So exactly, your sale is less. Your sale has been reduced by, in this hypothetical situation, by 20 times. Your sale is 5% of peak. Okay. So now this is where you can use KNN. You can forecast when your sale is going to be greater or when your sale is going to be less. Okay. So that is one use. Now let's see. So KNN is, so you have KNN. This is, what do you call it? This is, it works best when you have more features. More features in the sense when you have more data. So let's say I have two data sets. I have dataset 1, I have dataset 2. This has 5 columns, 1000 rows. This has 20 columns, 1000 rows. Now, if you apply KNN to both these data sets, ideally it will work better here. Okay, it should ideally work better on this second data set. Of course, there might be a scenario where your first data set is literally a perfect data set. Okay, so that can always happen, but you always want more features. Remember, the more features you have, the better chance it is for your model to work. Okay. And then we come to K. K is number of data points, right? So how do you find K? You can take the square root of n. If your n is 100, that is the number of data points, you take 10. Okay. Similarly, you can also use the same logic that we have used in k-means. If you remember, we created a list, and that list goes from 2 to 10 or something like that, and you pick the ideal number based on that. Okay, but you need to find the ideal number, since if k is lower, then you have overfitting. You might run into a situation where you're getting overfitting information. Okay, and if k is higher, then again too much time wasted on computational speed. Okay, so again you're wasting too much time. If you are ideal number of k is 10 and you're plotting for 100k, you're just wasting your time. Okay, and then of course, if you remember, we saw this elbow method. Wherever this elbow point is, that is your ideal value of k. All right. So this is k-means. K-means again, very simple, very easy to implement. It's probably the easiest algorithm supervised learning you can implement. Okay. So what are some of these advantages? of using k-means, k nearest neighbor, sorry. The advantage is it is very simple, very easy. You'll see in the implementation, it is probably one of the easiest algorithms you can implement. Okay. And then you don't need to do any sort of fine tuning of the model. Okay. You don't need to make any assumptions aside from the existing assumptions that are present within the data set. You don't need to make anything like, so you don't have to do hyperparameter tuning. Now, hyperparameter tuning is the bedrock of improving the performance of supervised learning algorithms. Now, if you don't have to do that, all of the sudden you're in a situation where your work is reduced massively. Okay, it is reduced massively. And then this is versatile. So this can be used in regression or classification. So it can be used for any of the supervised models you come across. It can be used in that. Okay. So these are the advantages. Okay. Now, similarly, you have disadvantage. So what is the disadvantage? It slows down a lot. So it slows down a lot when the number of examples, like your data set size increases, and the number of predictors increase, the number of variables increase. So again, you end up with the same situation. You need more data, but if you have too much data, then your model is not going to work. Okay. So this is not as useful where you need faster prediction. Okay, it's not useful there. All right. And moreover, like you have other algorithms, you have so many advanced latest algorithms in classification or in regression that you don't even need to think about KNN. Of course, KNN is useful. Okay. It's not like this model is not at all useful. It is very useful. Okay. It is very useful in prediction. It is very useful in pattern recognition. Now, one of the things that we saw in k-means was, or unsupervised in general, one of the things we see is that it is very, how do you say, it is very useful in finding out the patterns. Okay, similar thing you can do in KNN. You can find the patterns within the data set. You can find how the data points are related to each other. How is it going to work if you add more data? Where are those data points going to be stored? What category they will fall into? What prediction level will they fall into? Okay. So, while this is a big disadvantage, you can simply always improve your slowness by increasing computational capability. Now, if you feel like your k-means model is not performing well and all you want to do is build k-means, let me show you something. You go to Lambda Labs and you buy this laptop for 3,500 USD. That is around what? That is around 3 lakhs. So you get the latest NVIDIA RTX. You get the virtual RAM. Okay, you get a high quality high-end i7 Intel. You get the RAM. You get the storage, 2 terabyte of SSD. So now you can build whatever you want for your KNN. So if you feel like that is your issue and you only want to work with KNNs, you can do it. Okay. And the reason why KNN is still relevant is simply because it is very useful in identifying similar objects. Okay. So it is just very useful in doing that. Okay. And an example for this would be recommendation system. Now, what do you understand by a recommendation system? A recommendation system, as the name suggests, it would recommend something to you. Okay. So let's say you go on Amazon and you will, over the time, you will build up some history. If I go on Amazon and if I search something, I will find stuff that I have searched in the past. So if you search for example, what do you call it? For example, you're searching for clothes, you'll find similar clothing items. Okay. If you're searching for active wear, you'll find active wear. If you're searching for maybe semi-formal or formal, you'll find, yeah, earphones, electronics, food items, you know, whatever whatever personal items you're ordering, whatever, you know, electronic or grocery items you're ordering, it will suggest you items similar to that. And at the same time, it will suggest you items based on user similarity, how similar you are to other users. So if you have one user who is also searching the same things and he is finding something interesting, let's say I'm searching for active wear. Okay. I am searching for active wear. And then I have person two who is also searching for active wear. Over time, our search history is quite similar. We don't know each other. I don't know who this person one two is. I could be sitting in Punjab and he could be sitting in Assam. Okay, it doesn't matter, but we are searching for similar things. And then he searches for something, let's say a coffee mug. And this coffee mug is something to do with some sport. And I have also searched for similar sport related items. Not this coffee mug, but similar items. Now I would get this recommended to me that, hey, users similar to you are buying this thing. So are you interested in buying? So what it is doing is it is taking the similarity and it is making it more efficient and it is recommending it. Okay. So that is KNN. Now there isn't much explanation for KNN. Okay. So we will not waste a lot of time on explanation today. Okay. But let me see if there is something we can use. feel like I am forgetting something. Okay, so no, I think I have covered basically all of the theories. So we are just going to use KNN for nearest neighbor search. Just basically searching throughout the data points to find the nearest neighbor. Now, again, we have already seen how this can be useful. It can be useful in recommender system and things like that. So now we'll take a look at some coding. Okay, so let's start. So again, libraries, pandas, numpy, matplotlib, cbon, standard, right? These are all box standard, right? There is a standard libraries that you'll be using in every data science related algorithm. No matter what the algorithm is, you'll be using it. And then we'll be focusing on sklearn. So from sklearn, we are taking the standard scaler, standardizing the scaler. We are taking pre-processing, model selection, metrics, and k-neighbor classifier. All right, so these are the libraries we'll be working with. Now let's load our data set. We have to run. Let me just restart. Okay. So this is our data set. Now we'll quickly understand this data set because it is a bigger data set than what we have seen previously, and there's more things to explore in this. Okay, so we have order date and the time. So these two are basically at what time the person placed their order. Okay, so you're just keeping a track. As soon as the order was placed on the website, it is taken. Now then you have aging. What is aging? Aging is membership time. How long this person has been membership, has how long this person has been a member. Now if you go to if you are in Amazon and you are you know you have a prime membership, over time you'll see that as your prime membership length increases, you might be getting more and more benefits. Okay, so similar thing we have here. You're taking Amazon Prime membership. Let's just use an example. This is not Amazon data. This is something else. Okay. So membership. Then you have the customer ID. Each customer has its own unique ID. Okay. And then you have the customer gender. Now, the gender may play an important role. No, no. Aging is in years. It's not in months. Okay. So you have gender. Now every time somebody signs up, they will have put a gender there. Now obviously, what do you call it? Obviously, the person ordering might not be the same gender every time, right? So if you're trying to do some gender based analysis of past record, you might run into a scenario where, let's say I have my Amazon account, and if I give it to a friend of mine, she's ordering some stuff, I am ordering some stuff. So she is ordering what she wants. She's ordering some girl stuff, I'm ordering some guy stuff, right? Over time, you might get a scenario where the model is confused and it is recommending you guy or girl stuff when you're trying to place that order. Okay. But anyhow, that is not relevant here. Just something that you might want to keep an eye on. Okay. And then you have the device type. Now you can either, let's, like if you have Amazon Prime or you have Flipkart or I don't know, Myntra, you can either download their apps. So you download their apps, and when you download their apps, they will ask you to sign in. You'll go, you know, you'll go there and you'll take a look at it, and you'll see what benefit it is there to sign it and all of that. And you'll use the app. At the same time, there might be people who don't want to use the app. There might be people who don't want to, you know, download the app, but there might be people who are not able to download the app. You know, somebody might have a device that is not supported. Now, if I have a flip phone, do you think I can download these apps? I cannot download Amazon Prime on a flip phone. I really cannot, right? So that is one thing. Okay. So we are taking a look at what device they are using. And then we are taking a look at what is their membership type. Are they a member or are they a non-member? Of course, it matters. Members, they get certain benefits. They get certain advantages for being a member, right? But in this scenario, it is also important because you might be eligible for certain uh, benefits that come from being a member. Okay. And then you have the product category. What is the category? You have autos and accessory, home and furniture. So like that, you have multiple categories. Okay. And then you have some key information. What is the sale amount? So you sold this car media player for 140. You've sold one quantity. Your discount was 0.3%, and your profit was 46. So you made a profit of 46. After all these expenses are taken into account, every other expense that you might entail is taken into account, and you are making some profit based on that. Okay. So now shipping cost is relevant to the area. Now, if I am shipping within the state, within a city, even if it is the same day shipping, it will be cheaper. But if somebody from Kerala is ordering something, just one more. Yeah. So if somebody from one corner of the country is ordering something from to the other corner, the fast shipping time might be different. Normally, it may say that, hey, it will arrive there in 1 month. but because you're saying paying extra, we'll give you this within 1 week. Okay. So that is order priority. So order priority is what we are taking a look at. Order priority here is our why. Okay. We are trying to classify customers based on how likely they are to pay extra for their order to arrive on early, or they are more than happy to take the normal shipping. And then finally, we have the payment method. Payment method is how they're paid. In India, you have credit card, debit card, pay on delivery, all those things. So that is what we are taking a look at here. Okay. All right. So now we have understood the data. Let's move forward. So you have all these columns and you have all these unique values. Okay. So we are just taking a look at them. Yeah. So now we are taking a look at all the numeric columns. You have aging. So the minimum for aging is 1. So basically you're taking a look at all the ages. Okay. How many ages? That means you're saying that we are only got the data of members. You understand? Members only. Okay. Then you have customer ID. Then you have sales. The lowest sale was 33, the highest sale was 250, and the average sale was 152. Average quantity was 2.5. Okay. And the average discount was 0.3%. And on an average, you're making a profit of 70 per item. So it is a very profitable business. You sold 50,000 items and you have made 70 per item. You're ending up with 35 lakh, whatever the currency here is. Okay. And even if you include shipping and everything, you're still ending up with a massive profit. Okay. Then we'll take a look at the info. So we have 5,000, 50,000, 1,1290 entries. And you might notice here that some of these values, they have missing values. Okay. Not a lot of missing values, but some are there. And another thing you might notice here is that it is taking 6.3 MB in your hard drive, in your RAM. Now, if you have a 8 GB RAM, this will take 6.3 GB. Sorry, if you have it will take 6.3 MB space within your Python processing itself. Okay. So as you move on towards bigger data set, it will take more and more entries. So now we'll take a look at the missing values. You have 1 or 2. We don't care if you lose 1 or 2 values, doesn't matter. Now we'll simply drop those NA values. Why? Because there are not enough NA values present within our data set for us to care about it. Okay. And then we'll take order priority. So you can see most people are more than happy to go with the default order priority. There are some people who are more than willing to say that, hey, take your time, no rush. If you want to deliver this product next year, you can deliver. I don't care. Then you have some people who are saying that, no, I don't want it in a week. I want it in 5 days. And then there are some people who are saying, I don't want it in 5 days. I want it in 2 days. So this is our classification that we'll be using. Then these are all the columns we have. Then we are taking a look at the correlation. As such, if you notice, there isn't any specific column here that has high correlation except for shipping cost, sales, and profit. Okay, so they are correlated to each other. Okay, then we'll use the label encoder. Some warnings are there, doesn't matter. Correlation negative. So correlation negative, what does it mean is, let's say you have X and Y columns. Okay, and they are correlated to each other, positive correlation. So that means when value of X goes up, value of Y will go up. Okay, that is positive correlation. Negative correlation between X and Y means when value of X goes up, the value of Y will go down. Okay, so that is negative correlation. Correlation can be between -1 to 1. At -1 and 1, it is there's perfect correlation, and at 0, there is no correlation. Okay. All right. So we have this data frame. So we have done some encoding. Okay. So now we have shipping cost, sales, and profit that are highly correlated. Okay. So here, I think we'll just also include shipping cost for now, because it is giving us some information. Shipping cost. So we have a X variable that is in an array. Okay, we have taken it as an array. And similarly, we have taken the Y as an array. So Y is 0, 1, 2, 3, 4. 0, 1, 2, 3. That means we have 4 unique values. Okay. So then we create a standard scalar. We fit transform X to reduce all of these to a small range. Then it is supervised learning. So what we do in supervised learning is we do the test and train split. We split the data between testing data and train data. Okay, we take the shape just to verify the shapes match up. We define K as 25. We are saying 25 Ks. Okay, you can obviously take less. So for example, we have how many columns do we have here? 16. So let's take 4. Let's say we want to take 4K. Okay, so we define K as 4. Now we'll let this model fit that random state. You can take any value. The reason why I take random state as 42 is because there was a movie and a book series called Hitchhiker's Guide to Galaxy, and in that they had a supercomputer who knew all the answers. Okay, to any queries in the universe. So somebody asked him, "What's the secret to the existence of universe?" And that supercomputer replied with 42. So wherever possible, I just try to throw in that 42. It's a bit of a niche reference. Okay, you can take it as you want. Now, at 2 case, it is the accuracy is lowest. Okay, so accuracy is 48%, but K value is 3. Now, if we take it to K value as 10, Now we'll let it fit again. Now we see the accuracy is improving slowly but steadily. It is improving. Okay. So now we'll do what we'll do is we'll take k as the square root of this number, the total count. Okay. It's roughly 226. Okay. So let's do that. Now it will take a little time for it to fit. Maybe it will not even fit. So here what we have observed is this model is not very accurate for the business problem we have in our hand. Okay. So this is essentially because the data set is so diverse, it is not able to make the prediction it needs to make. Okay. So that's why we'll not be using this. Okay, so while this is running, if you guys have any questions, you can ask. I think 225 might have been that random state is how randomly it is checking the values. It will not make any, it does not make any difference. As such, you can take random state to whatever values you want. Okay, we'll wait for a couple more minutes. We'll see if this actually finishes up. If it does not, then I'll let it run in the background. And tomorrow's session, first I'll share the results with you guys. Okay, all right, guys. Let's end the session here. We'll see the results tomorrow. I'll let this run overnight, and I'll also tell you how long it took for it to run for 225